Okay, this is lesson 11, and as usual, we're going to start at the GitHub page, click on Lessons, and go to Lesson 11, and then click on this raw link, copy that link, go to the terminal, and we'll go to our the working directory, the lessons folder that we have for the course, and then do a curl -o, paste that link, and hit enter. It'll download. Of course, you can always do a save as from the web browser as well if you prefer, or you can do a Command S and that'll do the same thing. And if you have this shortcut set up, it'll show you the last 10 files, and you can see lesson 11 is there, just downloaded today. And then we're going to source activate Python 3, and then Jupyter Notebook to open up the notebook. Okay, so we can click on lesson 11. And then we'll, so there's two things you can do to sort of reset your notebook. You can clear the output, but that doesn't actually do anything underneath. All that does is clears the output. For now, we can just clear the output because there isn't anything. We haven't run anything yet, so nothing has been saved. But if we had started running things, we wanted to sort of go back to a clean slate. We can restart the kernel, restart and run all. Or we can restart and clear output. We can try that now. We don't need to restart, but we can, and it'll clear the output. So when you turn in your assignment, it's best for you to restart and run all before you submit it. That way you know everything's working right, and when I get it, I see sort of the final output and not something intermediate. And it's just a nice way to handle your notebook. Okay, so today we're going to cover the basics of pandas. So we've seen pandas a few times now, and I kind of wanted to slowly introduce you, but now we're going to dig into some of the nitty-gritty, and after this week you'll have a lot of skills in using pandas to manipulate data frames and data sets and do data science with pandas. So we're going to use two packages today. We're going to use pandas and NumPy, and the standard abbreviation. So what we're doing here is we could just type import pandas, and that would bring the whole package into our working space, into our namespace. But the standard abbreviation in the community is PD. So we're going to import pandas as PD. So now when we want to use pandas, we don't type pandas, we type PD. And same thing with NumPy. Instead of typing NumPy, we'll import NumPy as NP, and we can use it that way. So we execute that cell, and now we've imported those things. So first thing we're going to cover is a series. So a series is like a list or like a NumPy array, but it's got some additional features. It's got all the extra things you can do with a column of a pandas data frame. Basically, it's basically one column of a data frame. So we're going to create a list here, and we print that list. When you want to print something in a notebook, you don't have to type print. You can just type the name of the thing, and it will render it as it is stored. So if you type print, you'll get maybe the same output, but you might get a cleaner version. For example, if you print a string, it will just print the string instead of with the quotes around it. But for most purposes, you don't need to use the print command. So there's a function called series. So this is pd.series with a capital S. This will work on a list or an array, and it will convert that to a pandas series. So we're going to create this thing called series from list and then display the value of it. And so this is now the series. So what we're seeing here is this list, and then each list has an index from 0 to the end of the list, in this case 4, and or the end of the series, and it's showing that we can refer to the elements of this series using this index. It also shows us that the data type is object. Object just means string. It's sort of a generic data type that we call string, or that we call object. And indexing is the same, so we can use, in this case, they're automatically indexed with integers, and so the third element would be, or index 3 would be the fourth element, in this case Yankees. So here we're going to make an array that has some random numbers from 0 to 1 using the np rand function. And just as we made a series from a list, we can make a series from an array. And another example, just like with lists or with arrays, you can use this notation to do slices. So you can start with element 3 to the end. So the other main data type with pandas is a data frame. And data frame you can think of as a table. So here we're going to make a two-dimensional array with NumPy, again using this rand n function. So this is now it's like the rand function, but the rand function was from 0 to 1. This one is from it's centered around 0. It's a normally distributed random number array. And so like we have in pandas, we had that series function. For data frames, we have a data frame function. So we can say take this two-dimensional array as an argument, and it will give us a data frame. And by default, it will just automatically use numerical indexes for the rows and the columns. So some terminology: the row indexes are just called indexes, and these are the columns. These labels at the top are called the columns. But if we want, we can specify the index and the columns when we create the array. So we're doing the same function here, pd.dataframe, and we're taking this same two-dimensional array, but then we're passing the index names and the column names. So now when we print when we display the value of this, we can see that we have now we have labels that are what we provided for the rows and the columns. So there's some other ways to convert list or series to a data frame. So we can specify the data, and here we're getting we're passing a list of lists, which will just generate this two-dimensional array. there's also this function transpose, which can be used to transpose the data frame. So let's say we have a table that we want that the rows should be columns and the columns should be rows. We can quickly transpose it using either dot transpose or dot t without the parentheses. This is a shortcut. They'll give us the same thing.
So when you use the
Mm-hmm.
where you combine the two lists,
Mm-hmm.
if they're not the same length, what happens?
If these two lists are not the same length, you should get an error. Or I guess it'll fill it with nans, which is might be what you want, but you'd want to be careful. And you can see that it's using. There's a question.
I was going to say, it seems like it adds it row by row. So just where you place it, it adds it.
Yeah, it will be by row. So what actually we're doing here is we are taking two series and combining them into a data frame. And in this case, it knows that. So when we sliced it here, it maintains the index of that series. So if it was totally naive to the indexes, you might think it would put these two values at the beginning, but it knows that the indexes are 3 and 4, so it sandwiches them that way. You can also create a data frame from a dictionary. So here we have, in this case, the column name would be the key, and the row would be the values, or the columns would be the values rather. So here we have column A will be this series from list, and column B would be this series from array. And we can also specify the data type when we create it. So here we're going to say dtype equals string, or this is analogous to object. So we can use this dtype. So yeah, even though we said string, that's the same as object.
What would happen if you didn't specify the data type here? Would it infer that the one is...
Yes, if you don't specify the data type, it will infer that. I have a little section about that in a minute. Yeah. So if you don't enter this, that's fine. It will infer what data types to use. You can also specify for each column individually what data type you want to use. There's another way to create a data frame from two series. You can concatenate the series. And you can specify the axis. So if you say axis 0, it will just concatenate them as columns, or yeah, basically all into one single dimension. And axis equals 1, we'll put them side by side. So this is our data frame now. We're going to work with this for a little while. So we have, right now we just have these columns, or these row indexes, and these column names. And I will pause the video here.